Hello. Okay, Devika, screen okay അല്ലേ?
So okay.
Okay അല്ലേ? Okay, so in the previous class we discussed about the Straussens matrix multiplication. Okay, so today also we are discussing the same because in the previous class lost connections and a lot of issues was there. So anyway, we have enough time. So and discussing the Straussens matrix multiplication. Okay, so uh, first we will discuss the concept of normal multiplication. Okay, so what is normal multiplication concept? Okay, this is normal multiplication. That is, suppose there are two matrices A and B. Okay, A and B of order 2 by 2 and 2 by 2. Then we will perform multiplication using this equation. Okay, Cij is equal to sigma k is equal to 1 to aik, cannot here, aik into pkk. Then you will get these elements c11, c12, c21, c22. Okay, that is for calculating these elements in the resultant matrix we will use this equation. Okay, or our traditional method is simple. uh, what is this element c11? C11 is a11 into a11 into a11 into b11 plus a12 into b21 plus a11 into b11 plus it is a11 into b11. This is into b11, then plus a12 into b21. Then we will get c11. Okay, then we will get c11. In this way we can calculate each and every element in the matrix C. Okay, so you know the matrix multiplication method, so I'm not explaining much more about that. So this is the uh, traditional method we are following to multiply two matrices. Okay, uh, okay. Any connection problems, Devika?
So okay.
Okay, so this is the matrix multiplication algorithm, and there are three for loops. Okay, for I equal to say j equal to, and for k equal to 0. So the time complexity is big of n cube in this case. Okay, here we are taking two matrices, square matrices of order n. So the time complexity is n cube. Okay, so now we are going to discuss another approach, that is divide and conquer based approach. Okay, so what is divide and conquer approach is, I will tell the approach at first. It's very simple approach. What we will do is that, suppose this is a 4 by 4 matrix. Okay, this is a 4 by 4 matrix. What I will do, I will divide this into 4 2 by 2 matrices. Okay, I will divide into 4 2 by 2 matrix. Similarly, this also I will divide. Okay. So in this way I will divide. That is, this is one matrix, this is another matrix, this is another matrix, this is another matrix. Similarly, this is another matrix, this is another matrix, this is another matrix. So there are 8 matrices. Okay, so this is also 4 by 4. This is a 4 by 4 matrix. Okay. Then what we will do? We will solve this. We will perform this. We will perform the multiplication uh, of this matrix. Okay. You can note here. This is considered as A11. By using the matrix multiplication approach, we will find the value of A11. Okay. What is A11? What will be the value of A11? A11 is equal to, how can find A11? A11 is equal to which matrices we want to multiply? Not here. For multiplying two matrices of order 2 by 2, we can use this approach. For multiplying two matrices of order 2 by 2, we can use this approach. There are four equations. There are four equations. C11 is equal to A11 into B11, C12 A1 into C22, A21 into B11, C21. In this way, there are four equations are there. Okay. For multiplying two square matrices of order 2 by 2. Then here what we will do is that we will divide this big matrix into small matrix of order 2 by 2, 2 by 2, 2 by 2, 2 by 2, 2 by 2. In this way, 2 by 2, 8 2 by 2 matrices are formed. Then what we will do? We will solve these problems. Solve these in this way. For example, C11. Then from this, I want to form a matrix like this. Okay. This is the resultant matrix. That is, C is equal to C11, C12. In this way, I want to create a matrix. This is the resultant matrix. So what I will do, this is the final C we want to obtain, which is equal to, there are four elements, C11, C12, C21, C22. Okay. How C11 is calculated? C11 is calculated using this equation. C11 is equal to A11 into B11 plus A12 into B21. Okay. So C11 is equal to A11 into B11 plus A12 into B21. Then what is A11? A11 is basically this square matrix. Okay. This is a 2 by 2 matrix. That is, A11 is a 2 by 2 matrix. Contains the element A11, A12, A21, A22. So this is multiplied with B11. What is B11? This is B11. Okay. Basically, we want to obtain a matrix C with 4 elements where C11 is there. How can obtain C11 is using this method. C11 is equal to A11 into B11 plus A12 into B21. That is, this is considered. Then what is A11? A11 is this matrix. Okay. A11 is this 2 by 2 matrix. Okay. Next, into B11. What is B11? B11 is this 2 by 2 matrix. Okay. B11 is this 2 by 2 matrix, this matrix. Okay, so here we want to multiply these two matrices, A11 and B11, using which approach? Using this concept. Okay, using this concept, we want to multiply those matrices and solve it. Then we will get one value. Okay, plus next what we want to do, A12. So this matrix is multiplied with this matrix. This matrix. Okay, this is multiplied with this matrix plus A12 into B21. That is, this submatrix should be multiplied with this matrix. Okay, that is A12 into B21. Similarly, we want to multiply two submatrices of order 2 by 2. Then we will get C11. Okay, then we will get C11. Okay, basically C11 will be a scalar value. These two are we will perform the multiplication on this. Then we will get a value that is plus A12 into B21. Okay, then we will get C11. Similarly, we will calculate other also. What we will do? How can get C12? C12 is obtained. We want to multiply this position C12. How we will obtain C12? C12 is obtained by using this equation. Using this equation, we can calculate C12. That is, there are two matrices A11 and B12, which is multiplied, then we will get a matrix. This is another two matrices. We will multiply, we will get another matrix. Then we will perform the addition of these two matrices. We will perform the addition of two matrices, then we will get C12. Similarly, we will calculate these terms C21, C22, C21 and C22. Okay, so this is the using these equations. Then we will get a matrix C. This is the procedure using the divide and conquer approach. Okay, so we can write this method in this way. Okay, so for example, this is the algorithm. There are two matrices A, B, and the order n is there. Then, if the problem size is less than or equal to 2, what we will do? We will apply the we will just multiply the elements. Okay, A11 into B11 plus A12 into B21. In this way, we will multiply and we will find the solution. If n greater than or equal to 2, then what we will do? We will divide the matrices into in this way. Okay, so divide the matrices in this way. Okay, then we will perform this task. This is performed. Here you cannot. First, we will call the same function with A11, B11 and size n by 2, A12, B21 with size n by 2. So, this is equivalent to this step. Next, we will perform this one. Second is A11 into B12 plus A12 into B22. So A11 into B12 plus A12 into B22. So this is another matrix multiple. We will call the same function with mm. With the A11 B12 n by 2, with A12 B22 n by 2 plus. This is basically matrix addition. Okay, this plus. So in this way, there are 1, 2, 3, 4, 5, 6, 7, 8. 8 recursive calls will be there. So this should be the divide and conquer approach. So what will be the time complexity? If n less than or equal to 2, it will take a constant time c. Okay, we can write it as 1, no problem. If n greater than 2, then we will call 8 recursive calls. Okay. 1, 2, 3, 4, 5, 6, 7, 8. Here, okay. Here 8. Because here 8 calls are made. Okay. And the size of each problem is n by 2 at that time. So 8 into t of n by 2 plus n square. What is this n square? This is the time for performing matrix addition. This time. This is not a normal addition, it is matrix addition. Okay, so it will take n square times. So we will get an equation like this. Okay, so we can solve it using Master's theorem. After solving it using Master's theorem, we will get the time complexity, which will be n cube. So this is the divide and conquer approach. This is another approach of multiplication. So the first approach is this method. Second approach is divide in this way, then using these equations we will get the matrix. This is the corresponding program, and analyze that program, then we will get the time complexity in this way. T of n is equal. This is also big of n cube. The first approach is also take big of n cube. Okay. So next we are going to Straussens matrix multiplication. Okay. So what is Straussens matrix multiplication means? It is also, it uses the divide and conquer approach with some modification. There are 7 equations, 7 formulas. Okay. Straussens 7 formulas. So P, what is P? P is equal to A11 plus A22 into B11 plus B22. What is A11? A11 is a submatrix. Okay. So what is Straussens matrix multiplication means? This is A11. A11 is a 2 by 2 matrix. Okay. We will find these A11, A12, B11, B12, A21, A22, B21, B22. These are all 2 by 2 matrices. Then Straussens matrix multiplication, calculate 7 variables P, Q, R, S, T, U, and V. So there are 7 formulas and 7 variables are there, P, Q, R, S, T, U, V. Then these 7 variables are calculated using 7 formulas. These formulas you should study by heart. These are the formulas. Then what we will do? What is A11 means? A11 is a 2 by 2 matrix. That is, if it is a 4 by 4 matrix, this one, A11, A12, this one, okay, A21, A22. This is A11, okay. Similarly, you can note others also. Okay. This is B11 matrix. This is B11. So this is B11 matrix. So then we will apply these equations and calculate P, Q, R, S, T, U, and V by using basic operation minus, plus, multiplication. Okay. Then what we will do is that we will calculate the value of C11. We want to get it. The final matrix C consists of 4 elements. This is C matrix. We want to calculate C11, C12, C21, C22. How we can obtain these? We can obtain these using another 4 formulas. C12, C21, C22. There are 4 elements in C. So these are the elements of C. These are the elements of C matrix. Okay. So how can calculate these elements? We can calculate these elements using this equation: P plus S minus T plus V, R plus T, Q plus S, P plus R minus Q plus U. Okay. What is P here? This is P, Q, R, S. This is already defined. Using that, we will create 4 formulas again, then calculate these values. Okay. So in this case, if n less than or equal to 2, it will take a constant time. Else it will take 7 into t of n by 2 plus n square. Okay. In the previous case, which is 8. Now here 7 into t of n by 2 plus n square. Okay. So you can note here what is 7. 7 is basically, there are 7 formulas. Okay. 7 formulas are there. So calculating that or solving that 7 formulas, we need this time 7 into t of n by 2 plus n square. N square is the time for addition or subtraction. Okay, you can note here C11, C12 is obtained by plus, minus, plus, 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 minus, plus. Only matrix addition or subtraction is used. So in that case, whatever addition or subtraction, it will constant, it will take n square time only. Okay. In that way, the recurrence equation is formed. Okay. So you can apply master theorem for solving this problem. Then you will get this result, which is slightly lower than n cube. So this is about the Straussens matrix multiplication. Okay. So you can expect this type of question from this section. Okay. So multiply the following matrices A and B using Straussens matrix multiplication. So you will given with you are given with 2 matrices A and B of size 4 by 4. Then what we want to do? Then we want to perform the matrix multiplication using the Straussens matrix multiplication. Okay, so I will give it as an assignment. Use this approach. Okay, so use this approach. I will just show this is, in this case, this is A11. Okay, it is simple. Basically, this method is simple. Straussens matrix multiplication is simple. This is A11. This is B11. Okay, this is B11. B11. In this way, you can find out this also. This is A12. This is A21. This is A22. This is B12, B21, B22. Okay. Then what we want to do? We want to calculate this equation. Sorry, we want to calculate this variable P, Q, R, S, T, U, V using this equation. This is basically matrix addition and multiplication. Okay. Okay. So after this, you want to calculate C11, C12, C21, C22 using this equation. So the method is simple. You should study these formulas. Okay. If the formulas are wrong, then you will not get the answer. Okay. So you should study in the exam also. You should study these formulas well. Okay. Else the answer will be wrong. So this is about the Straussens matrix multiplication. Okay. Next, so in the first portion of the module 4, we discussed a divide and conquer approach. Okay. Next, we are moving to. So this is an assignment. Okay. This is an assignment in this week. Okay. Next, we are moving to discuss the next portion, dynamic programming. Okay. So what is dynamic programming means? That is in the module 4, the second part, we will discuss dynamic programming. So it is used to get optimal solutions to the complex problem. Okay, you can note the difference. Optimal solution. Okay, to get the optimal solutions of a complex problem, we are using dynamic programming. This is another approach of problem solving. Divide and conquer is one approach. We discussed that. Now we are discussing, which case, dynamic programming. Okay. Now we are discussing dynamic programming. This is another approach to the problem solving. So it is always used to get optimal solutions to the complex problems. Okay. And there are several solutions that are there. We want to get the optimal solution from that. In such a situation, we will use dynamic programming approach. We can solve different problems using dynamic programming approach. Next, what should be the approach? So it is like it is similar to the divide and conquer approach, but with slight differences. Okay. So first we divide the complex problem into complex subproblem. We will divide the complex problem into complex subproblem. Okay. So next what we will do, find the optimal solutions. Okay. Find the optimal solutions to these subproblem. This is very important. We will try to find the optimal solutions to this subproblem. Okay. Then store the result of subproblem. We will try to solve the subproblem, and if we got the result, what we will do? We will store the result. Okay. So that is also important, very important. We divide the problem, and try to solve it, try to get an optimal solution of that subproblem. If the solution is obtained, we will store it. Okay, store the result of subproblem. This is called memoization. Okay, so this is called memoization. Memoization. Okay, memoization. Okay, store the result of subproblem. Then reuse. Why we are storing something? We want to reuse it. Why we are memorizing something? We may want to reuse it in the future. So similar to that, reuse the result of subproblem. So in the future, in some situations, we may want to reuse the result. Okay, that is called reuse the result of subproblem. So no need to solve the subproblem again at that situation. Okay, so no need to solve the subproblem again at that situation or at that time in the future. Okay, that's why we are storing and reusing. So these are very important. Store and reuse method is used. Then finally, what we will do? Finally, combine the solution. Combine the solution of the subproblem to get the final solution. Okay. So this is similar to divide and conquer approach, but with some slight modification. Okay. So next, the control abstraction of this problem, that is divide the subproblem into smaller subproblem. Okay. Then we need a table storage for memoization. Okay, for storing the intermediate result. That is the solution of each subproblem. The solution of each subproblem is stored in a data structure table. Okay, so this is important. Then we will combine. Bottom-up computation is performed. Then we will combine the solutions to get the final solution. So this is the control abstraction of dynamic programming approach. Okay. So first we discussed what is the dynamic programming approach, what is the use. First we discussed the use, optimal solution. Second is what should be the approach. Okay, so there are 5 steps. Then last we discussed the control abstraction. Okay, control abstraction means which are the necessary steps to solve this problem like that. Okay, so divide the subproblem into smaller subproblem, then a table storage or memoization needed. The solution of each subproblem is stored in that table. Then we need to combine. So this will be the format of the dynamic programming approach. A dynamic programming approach based program should include these 3 components. Okay. So this is about the campaign. Okay. So next we will start the next class. We will discuss some problems that can be solved using dynamic programming approach. Okay. Today we discussed matrix multiplication and Straussens matrix multiplication. Then dynamic programming approach and introduction. Okay. Okay. Thank you. Okay. Please give your attendance 1 minute. Okay. Okay. First, Akash Rajiv. Please give from Akash Rajiv. Okay. Okay, please give attendance in the roll number, in the order of roll. Akash Abhinand. That's Ajmal Agilsi Paul. Ajmal absent. Ajmal Anaga Anjali Anugrah. Okay. Next. Atul Devika. Dilna absent. Dilna. Okay. ഫാത്തിമ ജസ്ന. ഓക്കെ ഓക്കെ. കാർത്തിക്. ഓക്കെ. കീർത്തന. സിന. ഓക്കെ. ഹിജാസ്. ഓക്കെ ഓക്കെ. നെക്സ്റ്റ് നഫ നേഹ. ഓക്കെ. നഫ നേഹ. ഓക്കെ. then നിതിൻ ബാബു. ഓക്കെ ഓക്കെ. പ്രണവ് പ്രണവ് സി. ഓക്കെ. റസാന റൈസ ഖാലിദ്. റസാന നിഹാല. ഓക്കെ. റിസ്വിൻ റോഷൻ. റിസ്വിൻ റോഷൻ. റസാന നിഹാല. ഓക്കെ. റോഷൻ. റിസ്വിൻ. റിസ്വിൻ ആബ്സെന്റ് ആ. റിസ്വിൻ. ഓക്കെ. സഹലാബി. സഹലാബി. സഹലാബി ആബ്സെന്റ് ആണോ? ഓക്കെ. സഹല എൻ. ഓക്കെ ഓക്കെ. നെക്സ്റ്റ് സംഗീത് സാരംഗ് ഷാരോൺ ശ്രദ്ധ. സംഗീത് സാരംഗ് സാരംഗ്. ഓക്കെ. ഷാരോൺ ശ്രദ്ധ. ഓക്കെ ഓക്കെ. വൈഷ്ണവി ബേബി ശ്രീഷ്മ അഞ്ജിത ഷിറോണ വിഷ്ണു വിനോദ്. സഹലാബി ഇപ്പോഴാണോ വന്നത്? വിഷ്ണു വിനോദ് ഷിറോണ വിഷ്ണു വിനോദ്. ഓക്കെ. ആബ്സെന്റ് ഈസ് റിസ്വിൻ ആൻഡ് സഹലാബി. സഹലാബി ഇപ്പോഴും വന്നിട്ടുണ്ടോ? ഓക്കെ. ഇപ്പോഴും വന്നതാണോ എന്നറിയില്ല. ഓക്കെ ഓക്കെ. റിസ്വിൻ ആബ്സെന്റ് ആണ്. റിസ്വിൻ ആബ്സെന്റ്. ഓക്കെ ഓക്കെ. താങ്ക് യു.